In example number 2, we want to take an alpha value of pi over 3, and we want to find the complement. This is a little bit more difficult because you're not as familiar with working with that radian measure as you are with degrees. So since this is in radians, I need to figure out what is 90 degrees in terms of radians, and we've worked on that already. So we know that pi over 2 is the same thing as 90 degrees. So alpha plus some other angle, we'll call it beta, should be equal to 90 degrees. So in terms of radians, we have alpha plus beta should be equal to pi over 2. Well, we know the alpha value that's given to us, that's pi over 3. Our beta value is what we don't know. Let's erase this so that we stay consistent. Okay. And now we'll just move this pi over 3 over to this side. So we have a beta value equal to pi over 2 minus pi over 3. So we need to do this out right here. And this is definitely the part that's different doing it in radians versus degrees, because here we've got to get a common denominator. So let's slide this back over here. So our beta value is equal to pi over 2 minus pi over 3. The common denominator there is 6. So this is going to be 3 pi over 2 minus, whoops, not over 2. Let's erase that. 3 pi over 6 and 2 pi over 6. So what I've done here, and we'll put this as a side note, is to get pi over 2 into 3 pi over 6, I've multiplied the top and the bottom by 3. And so when I go across, this gives me 3 pi over 6. So again, just getting a common denominator. Same thing here, I multiplied top and bottom of this thing, multiplied top and bottom by 2. So I have 3 pi minus 2 pi, so it just gives me 1 pi on the top over 6. And that's our beta value.